Hello, in this presentation we're going to solve exercises on the properties of waves in general. Look at the figure below. Which letter corresponds to the wavelength? Recall that the wavelength is the distance between two peaks or crests or the distance between two troughs. So, if we return to figure 6, we find that letter A represents the distance between two adjacent crests. This is the first crest and this is the second, and letter A is the distance between them. Letter B represents the amplitude from the rest position to the maximum of the first crest. Letter C represents the amplitude from a trough to the crest, so from the minimum to the maximum amplitude. Letter D represents the distance from the beginning of the peak to its end. This is equal to a half wavelength. And letter E also represents the distance from the first trough to an adjacent crest, so it's equal to half wavelength. So, which letter best represents the wavelength? Yes, it's letter A. So letter A best represents the wavelength, which is the distance between two peaks. Let's check it. Good job. Let's move to the second question. On the figure above, which letter corresponds to the amplitude? Recall that the amplitude is the height of the peak above the rest position, or it's the height of the trough below the rest position. So, in this figure, as we have identified earlier, letter A represents the distance from one crest to the adjacent crest. Letter B represents the distance above the rest position. Letter C represents the amplitude from one trough to one crest. Letters D and E represent the distance of a half wavelength. Then, by eliminating, we can eliminate letters A, D, and E since they represent the wavelength relation. So, we can choose from the letters B and C. What's the difference between B and C? B is half the amplitude of C, and by recalling the definition of the amplitude, it's the distance from the rest position to the crest or to the trough. So it's best represented by letter B. However, letter C is equal to 2 multiplied by the amplitude of this wave. So the correct answer is B.